Hello everyone, welcome back to the lecture series on business mathematics. So, before starting our fifth lecture, let us see what we discussed in the last lecture. As you know that in the last lecture we have discussed several examples related to arithmetic progression, right? So, moving further, we are going to discuss about the harmonic progression. Harmonic progression in this lecture, right? So, we will begin with the definition of harmonic progression. So, let us see. So, for that, let A1, A2, A3, A4 and so on be non-zero numbers, right? We are taking A1, A2, A3, A4 to be non-zero numbers. This word is important, right? Non-zero. We'll see why. We say that we say that these numbers are in harmonic progression. These numbers are in harmonic progression if their reciprocals they are reciprocals. That means reciprocal of A1 will be 1 upon A1, reciprocal of A2 will be 1 upon A2 and so on, right? If the reciprocals in arithmetic progression, are in arithmetic progression, that is 1 upon A1, 1 upon A2, 1 upon A3 and so on is an arithmetic progression. Okay, so see here. We begin with the numbers A1, A2, A3, A4 and so on, and we are considering only non-zero numbers. Now we can observe that why we are considering only non-zero numbers, because to define harmonic progressions we are saying that the reciprocals are in arithmetic progression. So in order to take the reciprocals we are taking the A1, A2, A3 to be non-zero numbers, right? So what does the definition say? Let us see. Definition says that suppose we are having numbers A1, A2, A3, A4 and so on, and these are non-zero numbers, right? We say that these numbers are in harmonic progression if they are reciprocals. That means 1 upon A1, 1 upon A2, 1 upon A3, 1 upon A4. These are in arithmetic progression. That means the distance between 1 upon 2 and 1 upon 1, distance between 1 upon 3, 1 upon 2, 1 upon 4, 1 upon 3 and so on are equal. Okay. So let me give you an exercise. Find examples of harmonic progression. Instead, find three examples. Right? Find three examples of harmonic progression. I think it is not that much difficult. So you can easily find out the examples of harmonic progression, right? So once again, what does the definition say? It says that the numbers, non-zero numbers, in fact, non-zero numbers A1, A2, A3, A4 and so on are in harmonic progression if 1 upon A1, 1 upon A2, 1 upon A3, 1 upon A4 and so on. These are in arithmetic progression. Okay, so this is what the definition says. And an exercise for you, you have to find out three different examples of harmonic progressions. Okay, so let us put some remarks regarding the harmonic progression. Let us see the first one. Okay, so suppose that let A, B, and C. A, B, and C are in harmonic progression. We are considering that A, B, and C are in harmonic progression. So what does it means? Therefore, 1 upon A, 1 upon B, 1 upon C are in arithmetic progression, right? By the definition of harmonic progression, we are given that A, B, and C are in harmonic progression. So 1 upon A, 1 upon B, and 1 upon C will be in arithmetic progression, right? What does it mean? It means that therefore 1 upon B minus 1 upon A is equal to 1 upon C minus 1 upon B, right? Because these numbers are in arithmetic progression, so distance between second and first term will be same as distance between third and second term. So 1 upon B minus 1 upon A will be same as 1 upon C minus 1 upon B. We are going to simplify this term. I am adding 1 upon B on both the sides. So what will happen? Or in other words, I am taking this 1 upon B on left hand side and 1 upon A on the right hand side. So simply it will be 1 upon B plus 1 upon B is equal to 1 upon C plus 1 upon A. Since this is negative, on left hand side it will become positive. Similarly here, this term 1 upon A is negative. So when it goes to the right hand side, it will be positive. Once again, what we are doing, we are adding 1 upon B plus 1 upon A on both the sides, right? So from left hand side, 1 upon A will get cancelled out, and from right hand side, 1 upon B will get cancelled out. So you can observe that this is nothing but the 2 upon B is equal to 1 upon C plus 1 upon A, right? So see, we begin with A, B, and C are in harmonic progression, and we prove that 2 upon B is equal to 1 upon C plus 1 upon A, right? So it simply means that whenever you want to show that three given numbers are in harmonic progression, then either you have to prove this 1 upon B minus 1 upon A is equal to 1 upon C minus 1 upon B. This is also the method to prove that A, B, C are in harmonic progression. But instead, if you can just verify this term, if 2 upon B is equal to 1 upon C plus 1 upon A, then we can say that A, B, C are in harmonic progression, right? So this formula gives an another way to verify that A, B, C are in harmonic progression. You have to just verify, is 2 upon B equal to 1 upon C plus 1 upon A. That means 2 upon middle term is equal to 1 upon first term plus 1 upon last. If this happens, then we say that A, B, and C are in harmonic progression. Okay. Let us see the second remark. Once again, we are beginning with A, B, C, B in harmonic progression. So if A, B, C are in harmonic progression, then we say that B is the harmonic mean of A and B, right? Suppose A, B, and C are in harmonic progression, then B is said to be the harmonic mean of A and B, right? So you can observe that in this formula, B is the harmonic mean of A and C, right? Sorry, it will be A and C here. B is the harmonic mean of A and C, right? So from this formula, we can find out the value for B, right? So suppose A, B, C are in harmonic progression, then we mention that B is said to be the harmonic mean. So after simplifying this equation for B, we can have the formula for harmonic mean. Right, let us see how. So let us see in the third remark. Suppose that capital H is the harmonic mean of A and B, right? H is the harmonic mean of A and B. Let us see what does this mean. Therefore, A, H, B are in harmonic progression. Just now we mentioned in the last remark that if A, B, C are in harmonic progression, then the middle term B is said to be harmonic mean of A and C. So here H is the harmonic mean of A and B. It simply means that A, H, B are in harmonic progression, right? So here we have mentioned that if A, B, C are in harmonic progression, in first remark we have discussed that if A, B, C are in harmonic progression, then 2 divided by the middle term is equal to 1 divided by the first term plus 1 divided by the last term. So using this formula, we get 2 divided by H is equal to 1 upon A plus 1 upon B. Okay. Now let us simplify this equation for A. So first let us put 2 upon H as it is. Taking LCM on the right hand side, the LCM will be AB. So multiplying the first term with B, multiplying the second term with A divided by AB. Right? Now this is 2 upon H is equal to B plus A divided by AB. So H upon 2 will be AB upon A plus B. Right? So therefore H upon 2 is equal to AB upon A plus B. Again multiplying both the terms with 2, we will get H is equal to 2AB divided by A plus B. So this remarks gives us the formula to find out the harmonic mean between two numbers A and B. Okay. Once again, here we are proving that H is equal to twice AB divided by A plus B. It simply means that this formula gives us how to find out or how to calculate the harmonic mean of two numbers A and B. Okay. Let us see one more remark. So if A, H1, H2, H3, Hn, B are in harmonic progression, then H1, H2 up to Hn, H1, H2 up to Hn are called harmonic means, harmonic means between, harmonic means between A and B, right? So here we are discussing about only one harmonic mean, B, right? We are considering only three numbers A, B, and C, and we are saying that B is harmonic mean of A and C if A, B, C are in harmonic progression. Now, instead, here we are considering n harmonic means between A and B. So these are total n plus 2 terms A, H1, H2, H3 up to Hn and B. Suppose these are in harmonic progression, then we will say that this H1, H2, H3 up to Hn are harmonic means between A and B. Okay. Once again, we know that suppose we are having A1, A2 up to AN and so on, right? We know that if A1, A2 up to AN are in harmonic progression, then 1 upon A1, 1 upon A2, 1 upon A3 and so on are in arithmetic progression, right? So these are in arithmetic progression. Okay. So this means that distance between 1 upon A2 and 1 upon A1 is same as distance between 1 upon A3, 1 upon A2 is same as the distance between 1 upon A4, 1 upon A3 and so on. Right? Now the question is how to find out the nth term of harmonic progression An using this one 1 upon a1, 1 upon a2, 1 upon a3 and so on. We know that these are in arithmetic progression, and we know that if a1, a2, a3 up to an and so on are in arithmetic progression, then nth term can be find out using this formula a1 plus n minus 1d, where d is the consecutive difference. Okay, so here the first term is 1 upon a1, Suppose that d is the consecutive difference between these terms, right? So what should be the formula of nth term of this arithmetic progression, right? And after that, simplifying that formula for a, and you will get the nth term for harmonic progression. So again, this is an exercise for you, right? Find the formula, find the formula for the nth term of a harmonic progression, right? So this one is an exercise for you. You have to find out the formula for nth term of the harmonic progression. Okay. So after noting down this some remarks, let us move further and discuss some examples. We find the harmonic, find the harmonic mean of x divided by 1 minus xy and x divided by 1 plus xy. Okay. So we are given two numbers, x upon 1 minus xy and x upon 1 plus xy. And the question is find out the harmonic mean of these two numbers. So for that, let us begin with h. Let h be the harmonic mean of x upon 1 minus xy and x upon 1 plus xy. Okay, right? Now we know that if h is the harmonic mean of numbers a and b, right? If h is the harmonic mean of numbers a and b, then we have the formula. We know that if h is the harmonic mean, then h is equal to twice ab divided by a plus b. So we'll use this formula, right? So then h is equal to twice ab divided by a plus b. Say this is equation number 1, right? So now what we'll do, we'll consider a is equal to x upon 1 minus xy and b is equal to x upon 1 plus xy in equation 1. Okay, we are asked to find out the harmonic mean of x upon 1 minus xy, x upon 1 plus xy. So what we will do, we'll put a equal to x upon 1 minus xy and b, we'll put b equal to x upon 1 plus xy in equation 1. So what we'll get, therefore h is equal to 2ab. Now instead of a, x upon 1 minus xy into x upon 1 plus xy divided by a plus b. So it is x upon 1 minus xy plus x upon 1 plus xy. So therefore, let us simplify. See this 2 into x, multiplying the numerators, we are getting 2 into x. It is simply 2x square divided by. Now see this term. This one is 1 minus xy multiplied with 1 plus xy. Now you have studied the factorization in your school level, and you might have studied that a square minus b square is equal to a minus b, a plus b, right? This you have already studied in your school level. A square minus b square can be written as a minus b, a plus b. So here you can observe that this is the same kind, a minus b, a plus b. So it will be a square minus b square. So using this factorization property, instead of a we are having 1, instead of b we are having xy. So a minus b, a plus b is nothing but the a square minus b square. So 1 square, that is 1, minus xy whole square, that is x square y square. So it is 2x square divided by 1 minus x square minus y square divided by simplifying the denominator. Now see, the denominators are different. Here we are having 1 minus xy. Here we are having 1 plus xy. Right? To For this addition, what we will do? We will take the LCM, and LCM will be the product of these two terms. Right? So what we will do? We will multiply and divide this term with 1 plus xy, and we will multiply and divide this term with 1 minus xy. So what happens? It will be x into 1 plus xy plus x into 1 minus xy divided by multiplication, that means LCM, it is 1 minus xy 1 plus xy. Okay, so this is the numerator term and this one is the denominator term. Okay, so once again, on numerator we are having 2x square divided by 1 minus x square y square. Here x into 1 plus xy, x plus x into 1 minus xy. Again, in denominator we are having 1 minus xy, 1 plus xy. So this will be 1 minus x square y square, just using this formula a square minus b square, right? So what happens now? We know the rule that denominator of denominator will go in numerator. Denominator of denominator will go in numerator. So what will happen? This 2x square will remain as it is. So therefore h is equal to 2x square as it is, and denominator of denominator, that means this one, 1 minus xy 1 plus xy, it is simply 1 minus x square y square divided by this 1 minus x square y square will multiply this term numerator of denominator. So first bracket is 1 minus x square y square, and we'll simplify this bracket, x into 1 plus xy. So multiplying x with this bracket, x into 1 plus x into xy. So it is simply x plus x square y. Then again multiplying this x with 1 minus xy, x into 1 minus x into xy, it will give you plus x minus x square y. You can observe that this 1 minus x square y, 1 minus x square y gets cancelled out. Here this x square y cancelled out. So what is remaining in numerator? Only 2x square. And in denominator you can observe that we are having this term x plus x, that is 2x, right? X plus x, that is 2x. You can observe that this 2 get cancelled out. X get cancelled out. So what is remaining? H is equal to x. And what is h? H is the harmonic mean of a and b. In this case, a equal to x upon 1 minus xy and b equal to x upon 1 plus xy. So therefore, x is the harmonic mean of x upon 1 minus xy and x upon 1 plus xy. And this is your solution. Okay. Okay, so I think this is enough for today. We'll continue discussing examples on harmonic progression and harmonic mean in next lecture. Thank you.